This is the ATOS Q. Today we have the system in a manual configuration on a carbon fiber tripod, and we're scanning a die-cast gearbox. One of the strongest features for this type of scanner is the ability to change your field of view. This lets you adapt the system to your specific measuring task by choosing the resolution and accuracy that's necessary. For this part, we're using the largest field of view that's available on the ATOS Q, which is 500 millimeters. Using this remote control and the manual rotation table, it makes scanning fast and easy. For scanning this part, I've put some reference points on the turntable, and that allows us to move the part or the sensor between the scans, and the software can automatically align them together. Also, the ATOS Q is a very fast sensor, and we're capturing up to 12 million data points per scan. The ATOS Q takes advantage of all of the latest GOM technology. This includes the triple scan functionality, which allows us to capture data in even hard to reach areas. Additionally, the system uses a fiber optic cable connection, 2 fast cameras, and the latest GOM fringe projection techniques in order to ensure that we have very accurate scan results. Now that we've seen a quick overview for how the ATOS Q captures detail on a complex part, let's take a look at some evaluation in GOM Inspect software. The result of the scan is an accurate digital copy of the part. Even these very difficult to reach areas that we can see here are captured easily using the triple scan technology. In terms of resolution, this is what you can get from the ATOS Q using the 500 millimeter field of view. GOM Inspect allows you to create color deviation plots, do section inspections, check your feature locations, and do full GD&T analysis. An extensive set of alignment features, measuring principles, and reporting tools make this a very complete package. Also remember that GOM Inspect is free to use, so it's very easy to share your inspection results within your project team. So now we've had our first look at an overview of using the ATOS Q for scanning a standard sized part. Now let's take a look at a second setup of the system and talk about some more details of the ATOS Q. The ATOS Q comes in 2 different versions. There's a 12 megapixel version and an 8 megapixel version. You'll also notice how small the system is. The ATOS Q sensor head weighs only 4 kilograms, which is just under 9 pounds. This makes it very easy to take it with you to the job site. Another benefit for the ATOS Q is that it comes with 5 different measuring volumes. There's a 100, 170, 270, 350, and 500 millimeter variations. For the die-cast gearbox earlier, we used the largest measuring volume at 500 millimeters. This plastic part here requires more resolution than we had for the part that we scanned earlier. Therefore, I switched the measuring volume out to the 350 millimeter field of view and recalibrated the system. To make scanning even easier, I've set up the part on the GOM ROT 350 automated turntable. The GOM ROT 350 is controlled in the GOM software, so we can select 8 measurements here and start the scanning process. As we scan the part, you can see the data being built up on the screen as we go. You can see here just how fast and easy it is to scan with the ATOS Q in this configuration. Now that we've finished measuring the top side of the part, we need to flip the part over in order to capture the bottom side. To help us align the top and bottom scans together, I've put some small reference points on the side of the part. These allow the software to automatically combine the top and bottom halves of the part together. The result that we'll see later is going to be the high detailed mesh of the entire part. So now let's start scanning the back side. The blue light that you see projected on the part comes from a very sophisticated light source. This projection technique was developed by GOM to produce a very low noise data. This also produces a uniform speckle-free light. This light source ensures that we have the most accurate and repeatable data possible. So now both scans are finished and they're combined together in the software. So it's time to take a look at the results. Here's our scan result. We now have a high detailed mesh which is describing all features of the part. Since we scanned both sides, we have the complete digital twin, which we can join with its CAD file to start the evaluation. The first step is the alignment of the part to the CAD model. Both overall alignments and local alignments are possible inside GOM Inspect. Again, since we scanned the part from both sides, we can now analyze the thickness of the part and verify if the thinner areas are to specifications. The design of this part requires for a lot of GD&T style inspections. These are calculated on the scan data, describing the part in great detail and offer a very accurate and realistic evaluation. Reporting of the full analysis is done in the reporting space. Even from a black part like this one, you can see how clean the results are. Remember that GOM Inspect is available free of charge and can be used to share all the data in a way as you see it here on the screen. So what if we want to scan multiple parts? We've already seen the scanning speed of the ATOS Q in this configuration, and we also know that the GOM Inspect software is parametric. That means that we simply have to add the second, third, or any subsequent scan data into our original inspection report. The software will then automatically recalculate the inspection and deliver you a full trend analysis across all of your parts.